Tom. Got this. Okay. Are you ready for me to make you the presenter?
I am.
Okay, so I'm switching him over to him. He'll have control here in a minute. And what we want to tell you, this event is really an exciting event. It's based off of, we've been doing a high school event now for the last couple of years. What you're going to do is you're going to learn about the Raspberry Pi, how to program the Raspberry Pi, and the electronics tied into the Raspberry Pi. And then you'll go in the competition, you'll troubleshoot Raspberry Pi and how to code and things. So it's a great opportunity to help you prepare as we do these webinars, and Mr. Tom here leads it tonight. We will record these webinars. We will also save them as PDFs to help you get ready. Now this year it's a trial event. So that means we're learning as much as you're learning as we offer. What works? We make, anytime you design something new, you make assumptions. We want to test those assumptions. I would ask that if you've got questions about the rules of the competition, we save that for the last show. You can ask it. We'll answer it, but we'll probably post the answer so everybody will get it. The link that you saw that logged you for this webinar, we're going to make that link available to everybody else. There'll be resources in the folders so you can get them. So if we ask a question regarding the competition, we're not trying to be rude. We're not trying to ignore you. We ask that you write. Would be the best thing is to write me youngengineers@gmail.com and write the questionnaire, and that way we can share it and everybody's treated fairly. So if someone doesn't hear a question that maybe they could have used. Throughout some of the webinars, not so much tonight, but down the road, we'll also give you examples of the kind of questions you might see in the competition. Now here's a really good chance to see that you can use your hands. Everybody raise their hand for a second. Great. So you now know where those are. And when you want to speak, just raise your hand. We'll take your time. We'll do it. Tom DeToy has been with me from almost from the very beginning with Young Engineers of Today, and we've used this method quite a bit. Now leave your hands up. We'll put your hands down in the future because we're looking at your hands to see it. Because sometimes we ask you to vote on something. It takes a minute. Now I'm going to put everybody's hands down. I'm doing this now. Now, raise your hand if you have a question. Okay? Alvin and Daniel do. Let me ask Alvin first. Alvin, what's your question?
Are you allowed to store information in the Raspberry Pi?
No. We're going to have Raspberry Pis there. You can save it all you want, but you're not probably, if you use your Raspberry Pi in the competition, we're going to ask that you don't do that. Okay?
Okay.
That way it doesn't give anybody an unfair advantage. We'll see what the rules are about a one-page document. That would be it. Okay? And chances are very good we're going to provide the Raspberry Pi, so we may ask you in case we're short one or one goes bad. Okay? Let me go to Daniel here. All right? Daniel, do you have a question? Your hand's raised, Daniel. Do you have a question, buddy? You might write it to us, too. Go ahead.
Can you hear me?
I can hear you now.
What model of the Raspberry Pi that we should use? They have multiple models.
Yeah, that's great. Well, because of the cost and stuff, I would go ahead and get the Raspberry Pi 3, the newest version. And what's nice about it is you can reach out to the Science House. They'll sell it to you for $39 or whatever the cost is of these. But if you get the new one, you could use an older one. If you've got one around the house, will be fine. But it'd have to be version 2B. Yeah, you can't get the very early one. Ours is going to look slightly different then. Okay? So you want a version that has 4 USB ports on it, and you'd be all right. If you're going to buy one, buy the latest one because it's gotten pretty powerful. Now, the early ones, to give you a background on this, Tom DeToy and myself, we've been working with this early on with Raspberry Pis. In fact, the school where I teach, we were the first school in the United States to use Raspberry Pis. So in the beginning, they were always been great for doing what's called embedded or physical programming, where we take the computer, we put it in the object we're making, so think of a robot. But they weren't, you didn't really surf them on the net because they were kind of slow and things. That's all changed. They're pretty fast. Think of a moderately speedy tablet is what your similar speed. Okay? So you're not going to run a game, you're not going to run a modern game on it or anything, but it'll do most things you want. All right, so I'm going to mute. If that answers your question, Daniel?
Yes, you did. Thank you.
You bet. All right. And then Sharon. Sharon, I might be saying that all wrong. Let me unmute that. If I did, I apologize.
Oh yeah,
Patel?
hi.
Hey, how we doing?
I'm actually Sharon's son. I'm using his account. So
All right.
I'm just wanting to ask you, where do we buy this Raspberry Pi?
Well, you can get them from the Science Olympiad. You can get them from the Science Olympiad people. You can get them at Adafruit, but pay just $39. Don't pay a lot. You know, the cost is $39. Tom is going to go through the parts of a Raspberry Pi, and he can address some of that. Does that make sense, Tom?
Yes.
So he'll go through that as we're walking through the parts you might need. But I know the Science Olympiad has some Raspberry Pi in the parts, so I would reach out to them, okay? But
Okay.
if not, you're going to see what we have here, and you're more than welcome to use it. And you can get it on, here's the thing. You got it at Adafruit. You buy a Raspberry Pi, but they'll have these Raspberry Pi starter packs where they add a bunch of extra stuff on it. It makes it expensive. This is a $39 computer. You need a 5-volt charger, which he's all going to get to, but I'll make it real quick. 5-volt charger you find most cell phones. And then a mouse and keyboard you might find around your house. So you might get by with most everything. The electronics we're going to use to test, turn on LEDs and lights, very inexpensive. All right? Any other questions?
No.
All right, great. Well, with that in mind, I'm going to jump off and let Tom do his thing. And y'all, we're excited to see you. I'll be going up to Raleigh on the first event, and we'll try it off there. Thank you very much, and I'll be stopping in from the webinars from time to time. Okay? All right, Tom, you want to take over? It's all yours.
Sounds good. Thank you very much, Mr. Dubik.
Thank you. You bet, man.
All right, everybody. So today we're going to cover the Raspberry Pi. Obviously, we're actually going to be covering the Raspberry Pi for a while. But today we're just going to get introduced to it. Now, as this is going to be a more programming-focused set of events for the Science Olympiad, obviously that's going to be more of our focus during these lessons. Now, I have a Raspberry Pi myself. It's an older model, and it's not prepared for today, but I can set it up so that I can actually at least remote into it. So hopefully that can provide a useful visual aid during these lessons in the future. But as it stands right now, today we're just going to be going over the Raspberry Pi in general terms anyway, so that's not going to be strictly necessary. This is entirely new ground as far as a lesson is concerned for me. So naturally, as these things go, I'm going to do my best to be up to date on all the information and everything like that, but I might make a mistake here and there. I mean, we're all human. If you notice something, feel free to let me know. Obviously, I'm not perfect, but I just want to say that, beforehand. Also from the perspective of, keep a critical mind when you're learning all these things, because it helps you to learn the answers to these questions, and then you hold on to that knowledge for a much longer time than if somebody just tells it to you. At any rate, we're going to be going over just sort of basic introductory information on the Raspberry Pi today, maybe a little bit over the UI and what sort of programs exist on it and what you might, be looking at if you were using one yourself. The real sort of meat and potatoes of these lessons, that's not going to start today. That's going to start probably Thursday, maybe certainly next Tuesday, and then we'll go from there. But yes, so the Raspberry Pi, what is it? What exactly? I mean, you've heard about it. You've seen. I'm sure you've seen them before, but everybody sort of speaks of it in general terms. A lot of times, there's not a lot of explanation behind it. So, what exactly is this? Well, it's a fully functional $39 microcomputer, like Mr. Dubik was saying. Essentially, it has all of the functions of a regular computer. It's just very, very small. In addition, a lot of these parts are relatively cheaper because they're lower power processors and things like that. So it's a very inexpensive piece of equipment. In addition to it being a fully functional microcomputer, it also has Gpio pins, and Gpio stands for General Purpose Input and Output. So you see all these sort of pins on the side here. Those are pins that you can just plug wires into, and then you can send signals through those wires to manipulate electronics. Likewise, electronics can send signals in through those pins, and the Raspberry Pi can read those, and then you can program them to interpret it somehow or do something with that, like when you get an input on a pin, start a flywheel to spin or something. I don't know. Create your own immensely complex machine. Anyway, the GPIO pins are good for controlling, motors, lights, sound or sense buttons, switches, or other environmental factors. So since they are input and outputs, you can hook up input to them in the sense of switches or buttons or things that look for those, like microphones or LDRs, or you can hook up output like motors and lights and things of that nature. The Raspberry Pi itself uses a Linux operating system branch, which is based on a Debian called Raspbian. Now, this means that, well, show of hands, how many of you have interfaced or used a Linux operating system before in any form or fashion? Okay, a couple of hands. Cool. All right, so then you will be at least somewhat familiar with the interface that the Raspberry Pi runs. Those of you who have never used it before, don't worry. Linux is just like any other operating system. It sometimes has a few more hoops to jump through and a few more things you have to do. But by and large, because of that, there's also a lot more that you can do with it. Having more of sort of the internal machinery showing means that you can manipulate it more and do more cool stuff with it. So it's sort of a give and take as far as that's concerned. But by and large, Debian, Ubuntu, things like that, these are very friendly, user-friendly branches of Linux. Raspbian is no exception. So this is a graphic basically just showing all of the hardware elements that make up the Raspberry Pi. As you can see, well, hardware elements including its dimensions. But it's just general information about the Raspberry Pi itself on the physical side. So it's got the 40-pin. It's got a modem on it. It's got a Wi-Fi adapter. It's got a micro SD card slot, display port. I'll actually go through these in more detail in the next slide. So Broadcom is the chip maker. Now these chips are mainly used in the cell phone or tablet market. So in that sense, this is about as powerful as a mid-range tablet, maybe a little bit more powerful than that. But regardless, we're not looking at a liquid-cooled supercomputer or anything like that. But it's certainly enough to get the job done. And it's it's not like you're running on a Motorola flip phone chip or something like that. It's certainly more powerful than that. 1.2 gigahertz, 1 gigabyte of RAM, and it's a quad-core CPU. So even stuff like this, these are specs that would be pretty impressive for a computer. Well, about 10-ish years ago, I want to say, which ain't bad. The fact that we can miniaturize it to something that's 85 millimeters by 56 millimeters. So what? About, well, a couple of inches on each side, a few inches on each side. I think it's probably about 4 by 3, 5 by 3, something like that. Regardless, it's a very small piece of equipment. Now, the GPIO pins, or like I said, general purpose input-output pins, allow you to connect LEDs and motors and sensors and switches and buttons and, giant robots and things like that. Although you probably need a secondary power source for the giant robot, but theoretically speaking. But that's what that's for. So that's basically the Raspberry Pi's connection to the outside world. Otherwise, it's just like any other computer where it remains a fairly self-contained system. You can connect to the internet, but you only interface with other computers. It's not like your computer can turn on when, there's, like when you turn on the lights in your place or something like that, unless it's literally hooked up to the power switch, which probably wouldn't be the best idea. In that sense, a computer is sort of blind and deaf to the outside world. It just takes an input from the keyboard and mouse and then puts something out on the monitor. A Raspberry Pi is not necessarily like that. It does have the ability to interface with physical components, certainly much more readily than a regular computer would. The Raspberry Pi, or just the Pi, has 4 USB ports. USB Universal Serial Bus, you guys are very familiar with those. Just a sort of a standardized connection for various pieces of hardware, computer-related hardware generally, but not necessarily. But, you know, keyboard, mouse, speakers, microphone, tons and tons of electronics. USB is, I mean, everybody's familiar with USB. It has network capabilities. It has a LAN port as well as a wireless LAN port. So it's got a, well, it says Bluetooth Wi-Fi, which is strange because those are 2 different things. But okay. Well, at least in the colloquial sense. But anyway, it does have network capabilities, so you can connect it physically using like a cable to your router, which is part of the reason why I don't have mine ready right now. I need to go plug it into the router and plug it in and everything like that and set it up with a new network. But if I do that, then I can use my computer to connect to it remotely through my network. So it does have network capabilities. It has modern audio and video capabilities. So it has an HDMI video output. It also has a camera port, so you can hook a camera up to it or camera out. It has a 3.5 millimeter audio output jack. It has a display port, a DSI display port. So it has a lot of options as far as audio and video are concerned. So you can hook it up to a, you know, nice set of speakers and a good monitor and things like that, and actually have it output something. Now, granted, the graphics capability, you're not going to be getting 4K from it or anything like that, but you would certainly be able to interface with more modern equipment. The Pi can be powered by a 5-volt cell phone charger. So, you know, if any of you have like an iPhone or an Android phone or a Windows phone or something like that, that little micro USB you use to power it, you can use that same cable to keep a Pi on. Basically, that is the power cable for it. You know, if you think about how your computer has a power cable, that thing is a monster, and it's got like, you know, the regular 3-prong thing going on and everything like that, and it hooks up to the PSU, and it, you know, takes like 180 watts, and this is not like that. You can use a 5-volt cell phone charger to keep the Pi running indefinitely. The Pi operating system is installed into a micro SD card. Now, this is different from a traditional computer. Traditional computer has a hard drive installed on it, and then you put things on the hard drive, or you remove things from the hard drive. Maybe you add more hard drives later on, and when that hard drive fails, you remove it. But generally, those are a fairly permanent thing. The micro SD card, the fact that you can use that for a Raspberry Pi means that you can swap them out much more easily. So let's say you have one that has a particular branch of Raspbian installed on it, and it's also got, you know, all of your programming stuff on it. Well, you can swap it out for another one that has a different branch of Raspbian on it, and also has like the Pocket Edition of Minecraft and a bunch of other like Raspberry Pi games and stuff like that, and you know, sort of Python experimentation sandbox kind of place. So the Raspberry Pi does have the capability to just, you can swap out the SD cards on it, which does sort of increase its utility and its versatility. Now, keep in mind, the SD card must be at least 8 gigabytes, because between the setup of the file system and the installation of Raspbian and all of the additional programs that come with it, it does need to be at least 8 gigabytes in size so that you can get everything on there. But regardless, that is doable. Yeah, the Pi now comes with Bluetooth and Wi-Fi capabilities baked in. I have a Raspberry Pi B, I believe, or 2, depending upon whatever nomenclature you're going for. I think it's a B plus maybe. Anyway, it does not have Wi-Fi capabilities. Unfortunately, if I wanted to have Wi-Fi on this thing, I would need to plug in some sort of adapter into the Ethernet port. But for the 3, it comes with that. So you have the ability to just plug in to a table somewhere, once you've gotten the network set up on the thing, and just have it sit there and communicate with your wireless network at home, which is pretty cool, with no additional hardware needed. So in order to have a fully functioning Raspberry Pi, this is everything you would need. Now, like Mr. Dubik was saying, there are online vendors which sell everything as sort of a package deal, and that does tend to increase the price. You can purchase the Raspberry Pi on its own without all this additional stuff, but you'll still need it in order to get it up and running. So if you have this stuff, then yes, you can go down that path, and it would certainly be cheaper. If you're not sure, or you don't have some of this stuff, well, it's up to you. You might be better off going with the package deal or something like that. That's entirely up to your own discretion and judgment. But yeah, you're going to need a Raspberry Pi. You're going to need an SD card, which contains the Pi operating system. Obviously, if you buy an SD card from like Staples or something like that, you're going to need to install the operating system onto it. So you're going to need something that interfaces with it and everything like that. 5-volt power supply. Regular phone charger will do it, unless you've got some sort of weird phone. An HDMI cable, which will connect the Pi to a monitor, and a keyboard and mouse, a USB keyboard and mouse. I feel like that probably goes without saying, because a lot of you guys probably aren't familiar with Serial or some of the older protocols for keyboards and mice. But yeah, it's got to be a USB keyboard and mouse. Those plug into the Raspberry Pi. That's how you control it. Now, this is just a general sort of walk through the process. If you have a Raspberry Pi, you're more than welcome to walk through it with me, but that is strictly not necessary. I'm going to go through this so that you guys know for the future, and obviously for the YouTube video, so if you watch it again in the future, you can go through all this stuff. But if you don't have a Raspberry Pi available, don't sweat it. You can just watch this and revel in my rambling or something like that. Anyway, in order to get a Raspberry Pi set up, it is sort of a multi-step process. First you gotta insert the SD card into the Raspberry Pi so that it's got a hard drive to work with, essentially. Then you've got to plug the keyboard and mouse into the USB ports. Now, it's also important to note that there is a very specific order to this. Some of these things can be sort of moved around in order. Like you can plug things into whatever order until you give the Raspberry Pi power, and then it's important what's actually plugged in. But yeah, plug the keyboard and mouse into the USB ports, and then plug the HDMI cable into the HDMI port. So make sure the monitor is on as well. And then plug in the 5-volt power source. Now notice the 5-volt power source is last. You've got the USB and the SD card and the HDMI all being plugged in before the power is plugged in. And that's important because the Raspberry Pi automatically detects what is plugged in and changes its boot up protocol based on that. If there's no HDMI plugged in, when the Raspberry Pi is first hooked up to power, it will not send a signal out of the HDMI port until you restart it, until you literally pull the power out and put it back in. That's just because it does this kind of stuff in order to conserve power and run as efficiently as possible. So if you plug in if you forget to plug in the HDMI port and you plug the Raspberry Pi into power, even if you plug in the HDMI after it's on, it will not send a signal out through the HDMI. At least certainly this was true for older versions of Raspberry Pi. This also holds true for the USB and everything like that. It will certainly boot up happily without any USB plugged into it, but it will not, necessarily take that input after it's already been booted up. This is the sabotage game. I'm not entirely sure about this. But yes, this would be the home screen for the Raspberry Pi, certainly one of the more recent versions of Raspbian. As you can see, it's very minimalist. It's also very strange if you're not used to the Linux operating system, but this does sort of, well, it's reminiscent of a pared down Unix system. Or Linux, I should say, not Unix. That's a similar but different thing. So despite the fact it's got some weirdnesses, like it's got sort of a start menu sitting up here at the top and all the icons sitting up here at the top, and just how empty it is generally, it is probably pretty familiar. I mean, because it's a regular mouse-based operating system. Click on stuff when you want to do stuff. Just like everything you've been dealing with for probably as long as you can remember interfacing or interacting with computers. I don't know why I keep saying interfacing with computers. I'm not trying to be, anyway, as long as you've been interacting with computers. So it's got the sort of the standard operating system set up to it. Shouldn't be any surprises there. Now, if you click on Menu, it will bring up a list of applications. Again, if you don't have a Raspberry Pi available right now, or it's not hooked up or whatever, don't worry about it. I'm just going over this for sort of the academic interest, and just to go over it. We'll probably go over it again, you know, a couple of times or later on. Anyway, now, as you can see, the menu is separated into a few different things by default. This is generally how it comes when you first boot up the Raspberry Pi. It's a microcomputer that's marketed for learning and programming and things like that. So its operating system is optimized for that. It comes pre-installed with some programming applications for, you know, Python and Scratch and things like that. And those have their own little separate, you know, tab in the menu. So it is very clearly set up to be as friendly as possible for people who are learning how to program, or who want something that they can use for in a hobby sense. Now, as you can see here, in the screenshot, it's probably pretty hard to see, but there are a number of different programming languages or a number of different IDEs. IDE standing for Integrated Development Environments, basically code editors that are listed here. You've got one there's for Java, one there that's for I think it's Python, maybe. You got another Java IDE down below it. You've got Mathematica, which is something entirely different. It's not actually programming. Node-RED, which is sort of like you can create flowcharts to design the flow of your program. You've got a couple of different Python environments. You got Python 2 and Python 3. Now, the reason why you have Python 2 and Python 3 is because they're different versions of the Python programming language. You know, computer languages are living things, just like regular languages. And there are updates that are made to them, and things change. More features are added, features are taken away. Sometimes, you know, if they're deemed like unsafe or something like that. So you'll have different versions. Now, just like having like a new and definitive set of grammar rules coming out, like in a book, talking about how the current sort of state of language, including all of the words and everything like that, they do that with programming languages. They'll come out with a new version which has new stuff in it. Now, it's a little bit more cut and dry than human languages, because a lot of times we can communicate stuff and still understand each other, even if it's not generally proper grammar. I do it all the time. But with a computer, it can't really do that. You know, if you use an older protocol or something like that when you're trying to use Python 3, depending upon what it is, it might interpret it incorrectly, or it might say that this is not proper, you know, programming. It might say that this doesn't make any sense to me. I don't know how to process this. So in that sense, it's stricter than the language that you and I speak. But regardless, it follows the same sort of principles. Now, you've got Scratch. I'm sure you guys have messed around with Scratch before, Sonic Pi, and then Wolfram, which again is not a programming thing, but it is a cool little thing, and it's useful for programming. Then you've got Office applications. These are all different versions of LibreOffice, which is a sort of a free version of Microsoft Office under the new licensing, which is the general. I forget. I always forget what new stands for. Anyway, free and open source, essentially. You've got just the base program, you've got a spreadsheet program, you've got a presentation program, you've got a drawing program, you've got a sort of an equations creator, and then you've got a text editor. Then on your internet, you've got email, a web browser, another web browser link that just basically takes you to information about the Raspberry Pi resources, so information about how to program in it and tutorials and things like that, and then stuff like that. Then under games, you got Minecraft Pi and Python games. Minecraft Pi, it's the Pocket Edition essentially. Essentially, it's not one for one. It's an older version, and it's made specifically for the Pi, if I remember correctly, certainly in the newer versions. But it's, sort of a simpler version of Minecraft. Think of an older version of Minecraft, like Pocket Edition, and you've basically got the idea for what, Minecraft Pi is like. And you got Python games, just like it says on the tin. Simple little Python games. Games that are written in Python. They could be, like Minesweeper and Battleship and stuff like that. Nothing crazy. Accessories is going to be sort of a miscellaneous kind of area. So you've got a calculator, you've got a file manager, which is, to allow you to delete things and organize stuff. An image viewer, a PDF viewer, just basic standard protocol programs so that you can open up images and PDFs. SD card copier, a tool that will allow you to copy information from one SD card to another. Task manager, which will allow you to look at everything that's running on the Raspberry Pi, see how much, how many resources it's taking up, kill off tasks so they're no longer running, things like that. Very useful in case something like freezes on your Raspberry Pi or doesn't want to quit. Very useful if your Raspberry Pi is running slow and you want to figure out what's making it run slow, stuff like that. Terminal, that's the stuff in there is going to be the main difference between, a Linux system and like a Windows operating system. The way you interface with the terminal and the stuff you can do with it. You can do a lot of stuff with the Windows operating system as well, but anyway. And a text editor, which is a basic plain text editor. I believe Archiver is a zip program. It allows you to create zip files, compress them. Then under help, you've got, I also apologize, I'm getting over a cold. You've got Debian references and Raspberry Pi help. So you can learn a little bit more about Debian, the operating system, and then you can learn more about Raspberry Pi, specifically how to do stuff with it. The Debian reference is useful since Raspbian is a branch of it, so not everything's going to be a one-to-one, sort of translation, but for the most part, it's going to be a very, very similar experience, and a lot of that stuff you're going to find there, you're going to be able to use in order to manipulate the Raspberry Pi. Stuff like the terminal and some of the programs it's got and everything like that. Then you can click on Preferences to customize the Raspberry Pi desktop to your style. That's, entirely flavor stuff, but that's always fun. It's one of the first things I do when I get a new computer is I customize all of the look and everything like that to make it my own, despite the fact that it doesn't affect the running of the computer at all, but it's just something I like to do. So you've got other stuff too. You can also add and remove software, obviously how you would install or remove software. One of the interesting things about Linux systems as well is there are a number of sort of servers set up by various people, and there are terminal commands that you can use to just sort of download new software from those servers and install them automatically and things like that. So, you know, like something like Vim or Emacs, which would be like a very simple code editor or text editor, would be something that like you could download through the terminal. Means nothing to you right now. Might mean something in the future, which I think is pretty cool. But as always, context is important. Anyway, they created an add remove software function, which basically takes those terminal commands and puts them in the mouse environment so that you can, you know, click on stuff and do stuff like that. Appearance settings, yeah, allows you to customize the appearance. Audio device settings, if you plug like a set of speakers in or a set of headphones in or something like that, you can set up the settings for that audio device. Main menu editor, just like appearance settings. But you can also, in addition to that, customize what appears here. So like the different programs and stuff like that. Mouse and keyboard settings. Pretty self-explanatory. Raspberry Pi configuration, setting up, you know, how it boots up and maybe what kind of programs it has in startup and stuff like that. Then you've got the top left menu, which I'm sure everybody's noticed. If you can see it, I don't know how big these icons are right now on your screen, but you've got in the top left, you've got a set of icons. These are just quick launch icons, just like what I've got down here. You can click on one of them in order to start them up. You can go the internet, file management, the terminal, Mathematica, and Wolfram. Show of hands, how many of you are familiar with like Wolfram Alpha? Nobody. Okay, that's fair. Well, it's a very interesting thing. Wolfram Alpha is very useful for, you know, computing things. It's like Google, but for math. And I'll explain what I mean by that maybe after we get through the slideshow, because it looks like we're probably gonna get through at least most of it today. But at any rate, so we've got the top left menu, which has all these quick start things, and the top right menu has some more icons over here. That gives you quick access to Bluetooth, Wi-Fi, sound, in case you have something plugged in, the percentage of the CPU that's being used right now, so you can always keep an eye on that. If your Raspberry Pi is running slow, chances are you can look up there and see it saying like 98, 99%, kind of that kind of stuff. If it's running slow and it says 2%, something weird's happening. But anyway, that gives you sort of a quick look at how much CPU power is being used at any given moment, how hard it's working. Time. I don't think I have to explain what time is to you. Also, if we wanted to get deeper than just the superficial thing, that would be way too much physics from, you know, my knowledge. And eject SD card. Pretty self-explanatory. You click it, and you can pull out the SD card. Got to make sure you click that first if you want to pull out the SD card while it's running, though. That's an important thing. Now that we've gone over all these different things, we can take a little bit of a closer look at what's going on inside the programming tab. Now, BlueJ Java IDE, it says Java for older students. I think it's a better thing to say, you know, Java for more experienced users, more experienced programmers, because it all comes down to what you're comfortable with. It doesn't really have much of anything to do with age necessarily. It's more like, okay, I don't know what I'm, you know, I know what these things mean and what they're doing. I can use this. If you're not as familiar with IDEs, again, integrated development environments, basically places where you write code, you can always try Genie Programmer's Editor, Greenfoot Java IDE, which is a simpler IDE. The Genie Programmer's Editor is just is a really good editor for programming. Then you got Mathematica and Wolfram, which is technical computing stuff. Like I said, the Google of math, and that'll make more sense in a minute. Okay, yeah. Wolfram Alpha, computational knowledge engine. So Mathematica and Wolfram are technical computing. here's the Wikipedia definition. Technical computing is the application of the mathematical and computational principles of scientific computing to solve practical problems of industrial interest. So basically what that means is, you know, if I have 20 tons of steel and I want to take 5 by 5 by 5 cubes and take off this much from each edge and, a circle in the middle defined by this equation, how much steel am I removing from those cubes? And then when you take into account the 20 tons, how much steel am I going to have left over as scrap? Because then you can go like, oh, okay, so like maybe I can melt down all this scrap steel and actually just like reuse it. That was sort of a off-the-cuff example. A simpler one would be you can do stuff like how much air is in a ball that's, has a radius of like 6 inches. You can do something like that. In fact, let's see here. We go ahead and just get it opened up. So this is why I say it's like the Google of sort of math computation. Not just math computation, even though that's sort of redundant anyway, but computation in general. You just get sort of a search bar like Google, except in this you would enter in equations. So we could say, and it's got knowledge as well. So we could say the GDP of, let's do the United States. It'll sit there and it'll compute, and it'll say, okay, so the GDP quarterly, seasonally adjusted. And then we get an answer here. Doesn't mean anything to me because I'm not really an economics major. I know it's going up though, and this is in trillions of US dollars, so it's over 10 trillion. Since this is logarithmic, it's not like this is a smooth transition from 0 to 10 right here. There's a lot going on in the middle. But regardless, I don't know, maybe 11 trillion probably, maybe, potentially. Oh, latest result, 18.68 trillion per year. Hey, reading comprehension is important. But in addition to that, we can go, okay, so the GDP of USA divided by Star Wars ticket sales. Star Wars Episode 4, A New Hope, total U.S. box office receipts. It does interpretation like this, and then it gives us an answer, which is kind of ridiculous. So this is the United States GDP from May 25th, 1977 to February 20th, 1978, divided by how much money Star Wars Episode 4 made. The result is, well, for this year is $40,516.10. Is this useful to us? No. But I'm sure you could use this in a useful fashion, and who knows, maybe this is useful to somebody out there. Regardless, though, there's a lot that you can do with it. You can area of a 3-meter circle. Let's say area of a 3-meter sphere. Sits there and it parses everything that I'm saying. And 3-meter sphere, minims? U.S. minims. Okay, I haven't heard of that. Apparently U.S. minims are a unit of measurement as well, so it didn't interpret meter. There, 113 square meters. it should be, oh, it's the surface area. That's why you should ask volume. I'm going to blame that on being sick. Anyway, that's what that is. So the Mathematica notebook interface uses Wolfram, and then the Wolfram language command line interface, that's what Mathematica and Wolfram are, respectively. So Mathematica is a notebook that allows you to write things. It uses the Wolfram Alpha computational engine, and then Wolfram is a specific command line interface that you can use Wolfram Alpha with. Node-RED is software for the Internet of Things. Okay. Python 2 and Python 3 are popular text-based programming languages. Yes, Python is very popular. I will agree with that. Sonic Pi learned programming by making music. It's pretty cool. And then Raspberry Pi uses a special version of Scratch, which is similar to Scratch 1.4. Now, if you know Scratch 2.0, you can program Raspberry Pi Scratch, and if you know Raspberry Pi Scratch, you can program Scratch 2.0. So I'm sure, you know, in the future when we're going to be going over programming things, we might do an introduction potentially to programming by using Scratch. If we do, great. We can use Scratch 2.0, and you guys will be very comfortable with Raspberry Pi Scratch when it happens. If not, if we jump straight into like Python or Java or something like that, that's okay too. We might allude back to things in Scratch. Yeah, well, if we do, I can always explain what they mean by that and stuff like that. But yeah, so that actually does it for this presentation. Now, why don't I spend this time talking about what usually happens at the end of classes. Now, I should say I have a class at 8 o'clock. It starts at 8 o'clock. So I think generally I'm going to be ending the lessons right about now, because what I like to do is I like to leave it open for questions and answers, time. So if you have a question, you can always just, for the sake of quickness, because we can have multiple people asking questions at the same time, you can throw them down in the question box. In addition to that, so the chat box that you have, you can just type a question into the chat box and it will be, you know, sent to me as a question. In addition to that, I like to use that system during presentations as well, because it means that you can ask that question and then it can just pop up over in, you know, my field of view while I'm doing these, and then I can answer it for you, and then, you know, we can address it right then and there. So don't be afraid to use the chat box to ask me questions. That's generally what I do for the question and answer time at the end of the class as well. But I like to leave that time for everybody to ask any questions they might have, and then we can address them. And so there are, I believe, yes, there are poll questions as well, which is something that I do need to ask each class. It makes things a lot better for everybody involved, because I get a feeling for how, you know, the lessons are going, and then you guys can give me that feedback and we can, you know, adjust things accordingly so that, you know, it's the best learning experience for you guys. So I'll start out with the poll questions. We'll do question and answer, and then we will, you know, we'll move on from there. What programming language will be used for the competition? That is an excellent question. Is this presentation available online? It will be available in a YouTube video soon enough. Actually, I'm going to put it up tonight after I do both classes, and it should be available sometime later tonight, early tomorrow. But if you mean the PDF of this, not right now, but I can put it into the GoToWebinar interface. I can download the PDF and put it into the handouts section so that you guys have that. The programming language used for the competition. If I'm being completely honest with you, I'm not entirely sure yet. I want to say it's Python, but I could be wrong. At any rate, I will certainly know before Thursday when we get started on, you know, the actual lessons and things like that, and we will, you know, get ourselves very familiar with it and, you know, feel very comfortable with it. Anyway, first poll question incoming. Let me go ahead and ask that now. So here